basically I want to go over some more massing tips, but then we're going to get into floors, walls, and even placing doors. If you go to the class website and under resources and family downloads, if you can download the door that says single plane panel. It'll say door, single plane panel, hollow metal frame. Those of you taking computational practice, you've already downloaded that. Under resources and then family downloads.
Just that one?
Yeah, just the one that says door single. So a couple things, I don't know if you guys got my email that I just sent out right before I left and came here. Essentially, where we have everything pinned up, tomorrow there's supposed to be some kind of exhibit or someone else is using that space. And so that's why I said we were going to have to take down all of our work Thursday night, which is tonight. Peter Wong and some of the other professors around here have seen the work. You know, they looked at the exhibit. And there's an open house next week on Monday, and they would like that work to still remain up. However, since we can't use that space anymore, they've relocated us down to the first floor lobby right below. So basically you're right when you walk in, and we can pin up anywhere down there between the front door and the lecture hall. So actually it's pretty good exposure because everyone who's coming in for the open house, they're going to be checking in at, you know, kind of when you walk in, there's a little desk that's off to the right. There's going to be food and drink off to the left, and then, you know, everyone eventually will be making their way to the lecture hall. So it's actually a pretty good location to be. So tonight, if you guys can, take down your work and kind of transfer it downstairs. Just keep in mind that downstairs, I guess it's all wood in order to pin up on, so I guess you're going to need some pretty hefty pins to shove in there. I'll let you guys collaborate on that. The other part is where the desk is and also where the table is going to be on the right side and left side. So there's a table right now with like a red tablecloth off to the left, kind of as you walk towards the gallery. And then when you first walk in to the right, there's that wood desk. We can pin up around that, so you could use the boards behind there, but just be aware that, you know, people are going to be kind of sitting up against that, or, you know, could be standing near it. So you might, whoever wants to pick those spaces, you might just, you know, kind of get your work up a little bit higher. So good luck with all that. I know pinning into wood isn't that much fun, but I guess anyone pinned up down there before? Yeah. Okay. So you guys have the right pins to make that happen? All right. What's that?
Exacto knife blades.
That works? I was going to say either that or nails or something. Okay, so today what I want to do is kind of go over some massing techniques real quick.
Where's the download? The panel that we must download today?
Oh, it's under, on the website. It's under resources and family downloads.
Okay, thank you.
And it's the door single. We may or may not get to the door. Okay, so I'm looking around and I see everyone has some kind of mass, and you have your mass floors. I've also kind of modeled this up real quick, and I'm zooming in on my total area. I've got about 286,000 square feet, and I said, you know, roughly around 287. So you can kind of see that 287,000 square feet, you know, could possibly fill up quite a bit of the site, depending on how you organize your floors. And I've actually got this modeled in 3 different masses with a couple different voids cut, and then I've also used the join command to Boolean union and Boolean difference some of the intersections of the different masses. So I can show you exactly how we can get along doing that. I'm going to hide this site, and I'm actually going to do a permanent hide for now. So I'm going to right click on it, and I'm going to use the pop-up menu here and say hide in view and then element. Some of you were asking, if you happen to hide something permanently, how do you get it back? You can't use the sunglasses because the sunglasses are only for temporary hides. If you want to get something that you permanently hid, to get that back, there's a little light bulb next to the sunglasses. If you look right there. And when you click on that, it'll reveal everything that was hidden in red. And so you get this kind of red or pink box that goes around your view. And then everything that was a hidden element is something that you can select, and it's red. And then there's a button up at the very top that allows you to unhide, or you can also right click on it and also choose unhide in view elements. And then once you exit out of that light bulb, you have your element back. So what I've got here, I have my zoning mass. I have this other mass that I built and cut a void out of it so that I could get within my zoning mass. I also created a parametric mass that had to do with making a reference point and then some reference lines that twist around the reference point. And then I just made a quick simple mass that happened to be here. And each one of these has a different set of which one has what level each floor happens at. So I kind of alternated in some of these cases back and forth. So basically this middle one is every other floor. This one has floors pretty much on every level except for a couple spots. And then this other mass I did kind of the opposite every other floor. That was part of my twisting box. I'm also going to hide my zoning mass so we can look at this a little bit more as well. Any questions so far about massing? I know you guys are kind of just first doing it for this first assignment, and the purpose of this assignment was really just to get you familiar with the intuitive massing tools. Anyone having any kind of issues or trying to figure out how to manipulate something, from one floor to the other or one mass to the other? Any major problems right now? Okay. So, if you have multiple masses, and in this case I have 3, 1, 2, and 3, this middle one is one I made parametric, and I've got some instance parameters that are off to the left that I set. But if I click on Edit and Place, I created this mass similar to one of the exercises way back when, and you may not remember, but you can actually create within the in-place masses, when you're in the project environment, you can apply your points just like we were doing with the bridges. So I have a reference point that's in the center of each of these reference rectangles. I set up a bunch of parameters that just have to do with the angle of rotation of that point and also the height of where those points are located. So I can actually, with this mass, I created a height of 285 feet. If I change this to 300 feet, my mass grows and all of the other points grow with it. I created certain locations of where these other points would always be in relationship to one another. And then same thing with the angle of rotation. I can actually change the bottom and the top rotation and kind of twist my box a little bit more as we go. And every time you make a change and hit Finish Mass, your floors and everything will update for whatever shape that actually conforms to. The other thing is if you're using voids and if you want to actually go back in and manipulate your void a little bit more, you have to be in the mass in which you created the void. So in this first mass, if I go into Edit and Place, I can then tab over and you can eventually select the void. But to further manipulate it, if you turn on the X-ray view, that's when you can start to select either the faces to move, or the points, or however you want to create that void. And then once you left click into space, it kind of goes away again and cuts that void.
For the parametric mass, how did you create the planes? Did you have, like, you place the points and then how?
Yeah, so I'm actually going to quickly go over that exercise. Let me show you one more thing, and then let me just show you some of the parametric twisting tower, kind of do a refresh on that exercise. Because I believe I kind of quickly showed it to you in class number 5, and that was quite some time ago. One thing is I've got these masses joined together. Right now, again, my total square footage, of course, I just twisted my tower a little bit, so I'm at a little bit less now, 282,000 square feet. But I originally had also joined my floors. So if you have a couple intersecting masses, if you were to cut a floor at each level, you're actually kind of double counting on some of the floor area, because if I didn't join this mass with the other, if you look at, here is a floor level, and if you hover over, it tells you what level you're on. So on level 25, that little pop-up window told me it was level 25. When I look at that kind of pie wedge, it goes and overlaps this other tower. And so really, when I look at my square footage now, all I did was unjoin my towers, and I'm now up to 351,000 square feet. So if you have overlapping masses and then you did your different levels, you could be kind of double counting on some of your area, and kind of maybe making it so that your tower is a lot smaller than it really should be. So what we can do is, once you have two separate masses created, and again, these are masses that are created as an in-place mass for each instance. So it's not like I created each one of these in one mass element. I basically did one mass as and I called this one like hotel version 1. I did this one as hotel version 1 lower, and then this was lower number 2. And so each time I created a new mass, and it'll show up in your families. So under mass, you can see I have 3 different masses here, plus my mass for zoning. So what you can do is, when you have intersecting masses, you can use, over here, there's the cut tool and also the join tool. I can join these two together by just clicking on join, and the first one that you select is the one that's going to remain, and then the one that you select next is the one that's going to have particular intersections cut out of it. So watch what happens when, let's see if I can zoom in, and we can look at this intersection area. I'm going to first choose the larger mass and then the second one. You'll see that the larger mass remained and the smaller twisting mass got cut by that operation. And of course, if I reverse it, I did a Control Z. If I join the first one with the second one, you can see now I've got floor wedges that have a void through it, based on where this other mass kind of cut through it. So it's kind of like in Rhino or even AutoCAD, when you model, it's your Boolean unions and Boolean difference. The only thing is, by using the join, none of your pieces disappear. If I were to do the same operation with a cut, the first one that I pick is the one that's going to remain, and that second one, let's see, I think I did the same thing. So that remained as well. If you delete it, everything goes away. So I guess I'm not sure what the difference between cut and join is. It looks like it does the same thing.
If you join the floors, like let's say you have floors that are close to touching but not, or something, or you have like a mezzanine, is it gonna try to connect those since you're not selecting the actual floors?
It's just going to be doing the massing. So it's basically if your massing's touching, one's going to cut the other. If they're not touching, nothing's really going to happen.
Okay.
So yeah, the floors are just kind of a result of wherever your levels happen to be, and then the resulting geometry of the mass. So I guess really in this case, using massing, cut and join do about the same thing. I was kind of thinking if you use cut, the second item should go away. But it kind of makes sense, I guess, if I delete one of these, the cut actually goes away as well, because it doesn't have anything to reference. So you could actually, build up a couple different masses together, and then what I did is in my mass floor schedule, if you look to the right, it's actually a little more complex now because I organized it based on hotel volume. And I'm going to show you a couple tricks of how to work with schedules. Because once you know this, then you can schedule anything and basically sort and filter and do whatever you want. With this schedule, and maybe I should zoom in on it a little bit. You can see I've got doesn't really help. I have hotel version 1. That was the name of my mass that's over here to the right. I have hotel version 1 lower. That's the same thing as this volume to the right. And then the lower number 2 as well. And each one is totaling up all of its square footage. So I've got a subtotal. And then at the very end I have a grand total to kind of track all of these different volumes. If you have a mass floor schedule, if you open it and you look at your fields, I basically added a new field from the left side, which is your available fields that you have. And it was called mass family. Because we created a mass, in-place mass, we're creating a family. And the mass family is the name of whatever you actually named your mass. So that's where I'm getting the hotel version 1, version 2, and lower and all that kind of stuff. Under formatting, this mass family, I made a hidden field. I'm going to unhide that for a minute and look, and you can see that each one of these items now has hotel version 1. It basically has the name of the mass all consecutively in the left-hand column of where that field occurred. Basically what I was just doing is trying to organize and sort these together. If I go under sorting and I sorted this by mass family, I'm basically organizing all the hotel version 1s to be together, and then the hotel version 1 lowers to be together, and so on and so forth. You're basically grouping anything that has the same name together. So if I actually group this by level, this would change around, and I'd actually have level 1s, level 3, and kind of a mess actually. Go back to... And then you have some other options up here in your scheduling so that after you sort something, you can make it a header that basically gives it its name, puts it above the list, and then the footer, and then you have some options for what can be in the footer, and basically it usually has to do with calculations, so totals and counts. So that's how I'm getting the subtotal underneath here. And then at the very end I have itemize every instance, which means show every time I have a mass floor that's in that mass. And then I have a grand total so that I'll get a total at the very end. The other part to that is if you're totaling items, you have to go to that formatting and then click on the field and make sure that you're calculating totals so that it will actually put something in the footer, and then it also has in the grand total. So I'm going to bring that back. And so basically by sorting by that mass family, And after going back in and hiding under formatting, if I hide the mass family, I don't need to see that, header basically repeat all the way through my schedule. I just want it as a title for each of these boxes. So that's when you would hide a field, is so that you can use it as a header in a sorting mechanism. You can also filter. So let's say I decide I don't want in this particular schedule to schedule anything that has to do with Hotel V1. So I can filter by mass family, and I can say make sure it does not equal, and then it gives me options to pick. Which item in that field I don't want it to equal. So if I click on that, hit OK, and zoom back out, I no longer see that hotel mass number 1 located, and then of course my grand total is only totaling up these two. It's not that big a deal maybe when we're just kind of looking at mass areas, but as we get into doing a door schedule, there's a lot of filtering that you need to do and hiding, as well as any kind of other quantities that you want to look at, especially if you're doing like a cost estimate. You might have a couple fields that you want to filter out and just say, I just want this particular schedule to give me the cost of, division 9 in the specifications, and then you could have that only show up in there instead of showing all the divisions. So that's kind of a quick lesson in scheduling. So it gives you the ability to give yourself some organizational tips. Exit out of that. And now I'm going to show how to quickly make a twisting tower with some parameters. Let me get rid of this guy. So I'm just, I still got my site hidden. I'm not going to worry about where I'm placing all of this. I'm just going to build it off to the right in this white space. But I can create another massing, and I'm going to do an in-place mass, and this time I'll just call it a, twisting tower. And once we do that, we go into a sketch mode where we're actually now in the conceptual design environment. All of our toolbars have changed. And I can place a point. So again, you start to see we get our point element that we're very familiar with now. We get that as an option to come back. And that's always a reference point. And I'm going to place this point, the very first one, on level 1. And I'll just place it off to the side somewhere. And again, like we always do, we turn on our show always, our reference for that point. And then within this mass, I'm going to create a couple of parameters real quick. I'm just going to call it L for length. And I'll make it an instance. And I can do a W for width and make that an instance. And then all I'm going to do is draw a couple reference lines, but what I want to have happen is I want the reference lines to be equal on either side of this plane, so that basically this point is representing the center point of rotation for each of the floor lines that we're going, or these profiles. So I'm going to click on line and also make sure I'm drawing a reference. If you accidentally draw a model, remember you can always turn it into a reference. But when I place this point, I actually want to pick. So, we have a lot more levels now to scroll through, so you might have to scroll down to the bottom and choose the pick. And then we want to pick the horizontal plane of that point, because I basically want to make another profile on this plane, and it's going to rotate as this point rotates. Next thing I'm going to do is draw that line again, and I've picked where I'm drawing on that plane. I'm just going to draw one at the center line in each direction. I'm going to make sure that I'm snapping to 90 degrees. And I'm going to offset, and for now I'm just going to do like, let's say 20 feet as an offset. And I'll offset this line on either side. And then you can use the trim and extend the corners to make a box. And then when you're done, you can just delete those reference lines that were part of the middle, because we don't need those anymore. The next thing I'm going to do is draw a aligned dimension. So it's already up here in my measurement tool palette up above, or you can go into Home and you can also find aligned dimensions. And I'm going to first do a dimension that goes to the center plane, not the point, the plane, the vertical plane of each of these, and I'm going to choose equal, equal. I'm going to do the same thing going in the other direction and choose equal, equal. And then I'm just going to do an overall dimension on each side as well. I'll pause for a minute, but I'm going to apply one of these to be the length, another one to be the width. And I better test it out to make sure it works. So I'm going to change this to 50. Change this other one to 25. So after you're done and you've set your equal, equal, your equality constraints, and then your overall dimensions, and you set those to either length and width, you want to go back into your parameters and change the values and test it to make sure that it's operating correctly. Everyone got that? Still working on it? I'll give you a minute. When you draw a dimension string, if you do, so I'm going from one line, I'm snapping to the vertical plane of the point and go to the next one. When you drag it off to the side, you'll have an EQ with a slash through it. Or if you just select, if you already deselected, you can select that dimension string again and that EQ will come back. And then you can place the EQ. And I have a error message that just popped up because I already have an equality setting set, and it's yelling at me saying I'm over constraining.
I can't select my parameter because it says line is too short.
Line is too short.
Yeah. It chooses to do.
Are your parameters set to 0 before you apply them?
Yeah. Okay, I'm gonna.
Everyone get your equal, equal. Okay, when you have your equal, equal, that has to be a continuous string. And when you apply your overall dimensions, those can only be one string at a time when you're applying them as parameters. And you don't have to lock anything. The equal, equal creates a lock for you. Test out your parameters to make sure that they're moving about the center. So I'm going to type in just some more different dimensions and make sure that everything grows about the center. I'm going to create another parameter, and I'll call this A1 for angle 1. And I'll also make this an instance, but we want to make sure the type parameter that type parameter is set to angle. And we can hit OK. So what we can do now is take this point, and because this is a reference point, off to the left you have additional parameters. that you can choose. And so we can actually take this rotation angle and then set it to equal A1. Then, before we continue, you want to test that when you change this angle in your parameters, so if I change this to 25, everything should rotate. Basically, what we just did is very similar to when we did the cross-section of the bridge. Before you did your sweep, we made the width actually change, and then it changed by the center point. It's basically the same concept, but we're now doing it in a horizontal way. So again, test your angle. It should rotate around, and so should all of your dimensions and everything around it. Okay, so the next thing I'm going to do is select all of this. And I'm going to copy it to the clipboard. And then when I paste it, choose aligned to selected levels. And then just for now, I'm going to pick, let's say, level 3, level 5, and level 7. And click OK. I'll Control Z that and do that again. Does everyone have this part worked out, the base? So select the whole thing. I windowed around it. I copied it to the clipboard. You can either click on this icon up here, copy to clipboard, or even do Control C on your keyboard. And then when you paste, click on the down arrow under paste and select align to selected levels. It'll bring up this dialog box that's asking you which level you would like it to align to. And then I just picked level 3, holding Control, level 5, and level 7, and then I hit OK. This way you don't have to set up all those parameters again. You're basically just copying it up. And if you change your length and width, if I go back and test things out again, all 4 of them now manipulate and change as well. Now, you're probably wondering why I didn't just do like every single floor level. You could go into that complexity, but even though we're aligning these 2 particular floor levels, what I'm doing is I'm actually just right now going to be establishing a height constraint, an overall height, and then making my other points in between just kind of evenly dispersed, from the start point to the top. I'm going to also do the same thing with the angles. So I actually need to create 3 more angles. I need an A1 through 4. So I'm going to do a A2. I'll make that an angle in an instance. I'm going to do an A3. That's an angle in an instance. And then also an A4. Angle instance. I'll also make an overall height, so I'll just call it height. Or I could just call it H, since we're trying to be short.
Is that an instance also?
Yeah, I'm making everything an instance. And I might make the H a value of like 150 feet, just as a default for right now. Then I also need basically H is going to be the top point, and we need also a height for these other 2. So I guess it really doesn't matter what we call them, but maybe call it IH1 for intermediate height. And I'll do IH2. Now basically what I want to have happen with the angles is I want to be able to control the bottom angle and the top angle, and then these other two angles can just rotate and try to morph in between so that I get a smooth twist. So angle 1 is going to be 0, angle 4, right now I'll set that maybe to 100 just so I have an easy number to work with. And basically my A2 and A3 need to be a formula. This formula would just be in parentheses. I'm doing this on A3 right now. I guess I need to zoom in here. I'm going to do the top, so A4 minus A1. That will give me whatever the overall angle shift is, because I could have a 10-degree angle on angle 1, and then I'd be getting the difference of 90. Then I want that to be divided by 3, because I'm going to have 1, 2, 3 spaces in between. If I put parentheses all around that formula, this will be added to A2. I can Control C and copy that formula down to the A2, and this time instead of plus A2 it'll be plus A1. And so what you can see is that formula makes A2 at 33.3 degrees, A3 at 66.6 degrees, and then 100. If I were to change the A1 to something else like 25, you should see everything else 25, 50, 75, 100. So it seems like it's working out to be equal, or an even distribution. The next part, I want my heights, my intermediate heights, to react in a similar way. So what we can do, and we don't really have a beginning height because that bottom of the tower is going to be at 0. So we don't have to really do a A4 minus A1 type of thing. I'm going to do, let's see, H divided by 3. Put that in parentheses. And this would be plus IH1. Control C and copy that down to IH1, and then just make that H divided by 3. So then you can see if my overall height is 150 feet, that second plane would be up at 50, the next one at 100, and the other one, the very top, at 150. I'll leave that up for a minute. Does that all make sense? I'm basically just trying to make an even distribution of where those profiles occur. And I'm just doing this as a preference. Obviously, you could, you might decide that you don't want it to be all equal all the way up, depending on how your parameters change. This makes for a smooth twisting form. Can I zoom out? Or are people still typing? Okay, so now I'm going to hit OK, and your items might react a little bit depending on what you were playing around with as your values. But now I have to set all of these correctly. Since we did a copy paste and we copied them all up to all the aligned levels, each one of these are actually equal. If we look at our rotation angle, they all have the same rotation angle. It's because we had them all originally equal to A1, and then we copied them up. So then what we need to do is go to the second one up, make that equal to A2. The next one up, make that equal to A3. And the very top one is equal to A4. And then each one of these, we can set the offset. So I'm going to start at the top this time, and over to the left under properties, if I select the point, there's an offset, and I'm going to choose that button. And the first one will be H. It's going to go up pretty high. The next one down, we'll make that IH2. And the next one down, IH1.
Is that offsetting that distance from level 1 or from the level that was placed on top of that?
Level 0. Because once we're now in this mode, we're not really, isn't really making associations and keeping it to the level 1 plane, because when we first placed this point, remember we placed it as a host to level 1. And so all of these other points are actually still referencing the level 1 host.
Okay. So it wasn't set as opposed to the level 2 station.
Right, yeah, that was just kind of a convenience of kind of putting it on a reference plane, but they weren't hosted to that plane. And for now, I might go back into my parameters and change all my angles back to 0, just so I get an easy loft here at the very beginning, so that I know it at least works at the start. And then all I'm doing is I'm selecting each one of these reference planes and choosing create form in a solid form. Once you do that, you can test length and width. Make sure everything grows how it should. And then I can start playing with the angles. Maybe start at 30 at the top. Maybe the bottom rotates 10. Maybe the top is even more drastic. And go to 75. So basically, oh, now I also didn't test the height. And then you can test the height. So I had it originally at 150. You could change it to 200 feet. And so you can see how your twisty tower quickly kind of can be adjusted on the fly. And this actually did come in handy when I was modeling my form in the middle, because when I twisted my tower, it poked out of the zoning mass. And so then I kept playing with the parameters until I got it to where the corner wasn't poking out, or I changed the width or the length. So that would be one good reason to kind of make a parameter. And then earlier there was a question about, well, what if you had a void and you wanted this to have a void that kind of twists with the form? You would kind of do the same thing, but you could set up a set of reference lines or reference points that are associated again with this center point. And if you drew another profile and made that a lofted void that goes through, I could make a little cut right here on each plane and then make that a lofted void. And if you have it set to similar parameters, or have it set to being referenced to this reference plane, the horizontal reference plane, no matter how that point twists and turns, your void should also kind of follow the shape of the solid. Whenever I'm done, I can hit finish mask. But because I made those an instance parameter, once I finish the mask and I select it, you can see off to the left I have a bunch of properties that I could still manipulate. So instead of having to go back into edit and place and change all the properties again, I could just come in here, because they're all instances, and then change some of my angles and or height without having to keep going back into the massing mode. So anyway, those are a couple different massing techniques. Next thing I want to do is get into, once we have our floor masses, what we can do with them. Essentially these masses, again, everything that's a mass in your model is always considered, and right now, before I continue, I'm going to take this mass that we just made and I'm going to delete it. It does go away. Never mind, I thought it would stay in the family environment. So I guess that's one of the downfalls of massing in place in your project environment, is if you decide you did all that work but you don't want this tower and you hit delete, it actually goes away. So again, you could also model all this stuff in the conceptual design environment as its own family, and then do a save as and actually bring it into the project environment and place it as well. But anyway, all of this, all of the massing elements, anything that you do with massing tools, are typically in Revit supposed to be kind of an underlay, and they're used as a way to generate form and apply real Revit components to it. So since we have all of our floor plates, let's see, so we have all of our mass floors, and what we want to do is actually apply a real mass, or a real floor element that Revit recognizes as a component in the project environment, and not just a design or a conceptual design tool. Because remember, if I hit VG and turn off the mass, everything goes away. So it's not really a real element that Revit really recognizes as something that we can later model to. So we're going to start going into sketch-based tools that have to do with floors. And if we click on Home, these are your main modeling tools in Revit when you're in the project environment that have to do with building components. You have walls, doors, windows. Components are just additional families that you can bring in. And of course, everything in Revit, there's always kind of a starting point. So whenever you click on a wall and click on the property down options, you know, there's already a set of walls that are already part of Revit. Same thing when you go into a door family, they have like one door loaded. There's all these kind of items that are already preset into Revit, but the way that Revit works is there always has to be one thing to start from. So there always has to be a door, or there has to be a window, or at least one floor assembly or something. And the way Revit works is you select that item, you duplicate it, and then we manipulate it to conform to what we want it to be. So under Home, our sketch-based tools are anything that's a horizontal plane. So we have roofs, ceilings, floors, and anytime we know that we're in using a sketch-based tool is if you click on, and I'm going to go into like a floor plan. So let's look at level 1 for a moment. I'm going to hide our site. ZF to zoom in. And when I click on floor, you'll notice that everything kind of grays out. And then I have I have a mode button up here, and there's an X, a red X, and a green checkbox. That's how you know you're in a sketch mode, is that anytime you're presented with a checkbox or a cancel button, basically, you're basically in a sketch. And what that means is you can't manipulate any of the objects that are grayed out, and it wants you to start sketching a floor. So I could draw, and all I did was click again on Home, and then I did Floor. And then I'm just going to, for right now, model with the generic 12-inch floor that's off to the left on your properties. I have boundary line selected, and I'm just going to go ahead and make a rectangle. I'll just do it like this. Anytime you're in a sketch mode, you have basically purple lines, and they're kind of this magenta line. That is what you're sketching. That is your sketch element. And when you're in sketch mode, you have to make sure that you're making a closed shape. So for instance, if I happen to sketch and I don't have these items closing over here at the end, and I try to exit by clicking on this checkbox, Revit will yell at me and say, give me a couple orange dots, and it'll say that lines must be in a closed loop. Do you want to quit sketching, which will basically exit out of this sketch, or do you want to continue? So I'm going to hit continue, and this works in the opposite way, so I can also drag. If I happen to have overlapping lines, I'll get the same error message. So you want to make sure that you're making a closed shape, and then when you hit the exit button, you will exit out, and we can go back to our 3D mode. And I'm down at the first floor, and you can see that we created basically a rectangular floor. Now when we click under massing and this button up here to the top left that says show mass, if I click on that, everything goes away except for that floor element, because that's an actual real project or project environment element that Revit recognizes as a floor. Now a couple things, let's just copy this floor up a little bit because I want to cut a section through it. Not worrying about the mass at the moment. I'm just going to select this floor. I'm going to hit Control C. Then I'm going to paste. I'm going to have to probably click around until I hit Modify again. Oops. And then under Paste, I'm going to do Align to Selected Views. And I'm just going to pick 2, 3, 4, 5, and 6 for now.
Where's the copy on it? Control C.
Control C, or under Modify on your tool palette, next to where it says Paste, you'll have a Copy to Clipboard, a Cut to Clipboard, and then also a Paste option.
Can you start back at making your mask go away?
Under Massing and Site, just press this button, this little pie wedge at the top left.
If nothing happens, just delete your mask?
No, you never delete.
Oh.
Then you're going to get rid of it. So hit VG and make sure that your mask is turned off. And then basically what that does, if your mask is turned off in the visibility graphics, this toggle button works then to toggle your mask on and off. If it's not going off, you probably had the mask checked also in the visibility graphics.
Jeremy, I don't let me say around selected views while I selected, but I copied too.
It says Align to Selected Views.
It's right, it's grayed out.
It's the second one.
Oh,
Align to
selected level.
Selected level, sorry. Sorry, I keep saying Align to Selected Views. It's Align to Selected Levels. Align to Selected Views is normally grayed out. Thanks. Okay, so I'm going to go back into, let's just go back into level 1, and I'm going to cut a section through this floor because I want to show you some of the tools with the floor. You're still in when you're still in a sketch mode. You need to exit out. So hit cancel and start over. So actually, you have your floor. You have your floor right there. Go ahead and left click on that. Control C, and then up to the top left there where it says paste. Click on the down arrow under paste, and then align to selected levels. And then I chose like 2 through 5 or 2 through 6. So if I go back into level 1, I'm looking at all this in plan. Under view, I want to cut a section and look at what this floor is looking like. So I can click under view and then section. It's yelling at me to save my project, so I'm going to save it. And basically cutting a section, we've done this I think before, but you're basically just drawing a line through where you would like your section to occur. And as you do that, you now have in your project browser, it'll now say sections, and you have a section 1 that shows up in the project browser. You can get to that section in a number of different ways. We could just double click on the arrow of the section marker. And again, what we can do with this section marker is I can drag this, wherever I want. I can click this rotate button. It looks like a rotate button, but it's actually a cycle button. It cycles through an arrow or a tail or none at all. And then I can also use my flip arrows and flip my section. I can double left click on that and it'll take me into my view here, and I've got my what happened here is when I flipped into this view, every time we flip into a view right now, we're going to see our imported site model. Remember the SketchUp model, and we're going to always have to turn it off. One thing that we might do later on is you might model, you might have your site model as a separate Revit model, and then do all of your massing and everything that we're doing right now just as you are. You can basically do a save as of this file, and we can link in the site model so that later on we can, turn it on. Otherwise, every time we make a view, we're going to have to go through these steps. But the easiest way to turn it off is go into VG, and imported categories is your Lower Manhattan DWG. You can just uncheck that, or you could also uncheck Show Imported Categories in this view and hit OK, and that will get rid of that site model. Because it's a model from DWG or a model from SketchUp, Revit does not recognize it as an object, and so it can't cut a section through it. So basically every time you cut a section, it's kind of showing you an overall elevation of it again. And so it's always going to hide whatever you're looking at. Same thing with mass elements. If you were to cut a section through a mass, like your towers, again, it would not really recognize it as a true element and not cut a section. So you can look at your floor and you can see you have these sections. And I could turn on my fine view. There's really nothing showing up in this floor. Let's zoom in on one of them and change our floor type to something that would normally be in a skyscraper or even any kind of building, even like this one that we're on right now, we're in. You select the floor, and under properties, there's one here called 3-inch lightweight concrete on 2-inch metal deck. Go ahead and just click on that. And I'm going to turn off the line weights up at the top here. And you can zoom in, and you can see that you have a corrugated metal, a metal deck. If you don't see this corrugated metal deck, I'm going to show you why. Okay? Yeah. So if you don't see your deck, guys, listen up. If you don't see your deck, cut a section looking the other way, because Revit assumes a certain direction of where this deck is going. And again, VG, imported categories, and turn that Lower Manhattan off. So if your 3-inch on 2-inch metal deck looks like this, if you just flip views. Now the way to control that is when you're, let's see, what level are we on here?
It's so much more now.
Excuse me?
There's still a setup.
Turn on your fine view. All structural elements have to be seen under a fine view. So right now you might be in a coarse view, and if in your coarse view, you're not going to see certain level of detail. Down at the bottom, you got coarse view, medium view, and fine view.
It's so much more than that.
Okay, everyone got that? But you might decide, for instance, that Revit assumed that your deck was running a different way than you thought it would. We all know that our structural deck is going to run perpendicular to however our structure is running underneath. Of course, we don't know what our structure is right now, but what I want to point out to you is, if I go back to this sketch, let's see, I'm on level 6, so I'm going to go into my level 6 floor plan. And if I select that floor, I can edit the boundary. Remember we made it as a sketch element. I can click under Edit Boundary. It'll take me back into sketch mode. Notice that on one of these edges, there's this like extra set of lines that are kind of going, in my case, they're going horizontal. That's indicating the span direction of your floor. So if I click on, you'll see up at the top, there are options like boundary line, slope arrow, and span directions. If I click on span direction and then choose another line, let's say the vertical line, I now just changed the way that my floor is running, and I should be able to look at my different section views and see that it switched from section 1 to section 2. It switched directions. Another thing with floors is, let's go back, look, since we're working with that one floor, whatever one that you're in, I'm in level 6 at the moment. You might be in a different one. But I can also click on this floor. I'm going to go back to edit boundary. And one of the options here is called slope arrow. I can actually click on that and then draw a line. You can kind of see when you start drawing the line, you have an arrowhead. I'm going to draw that. And we've actually done this once before, but kind of briefly. But when you draw that line for the slope arrow, you have what's called a tail and then an arrowhead. If you look at the left, if you have your slope arrow selected, it will say under properties, specify a height at the tail and a height at the offset, height offset at tail, and height offset at head. So I could come in here and let's just do something drastic like 6 feet at the tail. I'll keep height offset at head at 0. Now exit out of that and then look at this in 3D. And you can see that my floor is sloping now. Everyone get that? But now here's the thing. So far I've shown you how you can make your own floors, but we've already kind of done a massing study and we have determined our shape of our form. And if we were to continue with this method of creating floor slabs, what we would have to do is actually trace all of our floor plates. Well, that might be okay to do, but it's going to first take a long time. Second part is if you ever change your mass, you're going to have to go back and edit all of your sketches again because they're not going to be connected and Revit doesn't know that you want to, whatever happens with the mass to actually happen with your actual floor slabs. So I'm going to delete all these because I don't need it anymore. I'll just hit delete. And under massing and site, I'm going to turn on my mass again. And we've already created mass floor slabs. Now, under home, and this time instead of just choosing floor, there's a little down arrow under floor, and you can see there's some other options. There's floor, there's structural floor, and then there's an option called floor by face. You'll notice in the wall environment, or the wall tool, your roof tool, ceiling tool, and floor tool, well not ceiling, but floor, you all have a, so under floor you have floor by face, roof, there's a roof by face, and wall, there's a wall by face. Anytime you see by face next to something, that wants you to relate this object to a mass element. So we can come here and click under floor, floor by face, and then we can choose which of these floors we would like. Of course, we have to select them, you know, one at a time. That's okay, but I'm just going to do a few of these at the moment. Maybe I'll get into my twisting tower. And when you're done selecting all your different floors that you wanted, you can hit Create Floor. And now again, I'm going to close my mask. I thought I selected more than that. So anyway, I selected just a few floors, but what I want to show you is that now these are actual floor elements that we could come back in here and click on Edit Boundary, and they are sketchable items, but they're already at the default, they're set to whatever our floor mass happen to be. The significance of that is if I'm back in my mass, and let's say I decide to edit this guy. I'm going to choose, and this is one of those parametric forms that I have. I'm going to twist this around a little bit. Let's do 75. So I manipulated my mass, but notice what happened to my floors that I just created. Nothing happened, right? They still stayed. They're kind of poking out of the mass now. Because Revit doesn't want you to make that change until you acknowledge that that's something that you want to reapply your actual Revit materials to. So once you've done that, you can actually select all of these floors again, and then you have this button up here called Update to Face. And if I click on that, they will now update to however the mass floor got twisted or manipulated or changed. So if you happen to have all these floors, so let's say you created all of them as Revit floors, and then you started cutting voids, you know, through the mass, or you don't have to necessarily cut, let's say, elevator shafts and stair shafts with mass voids. We'll get into other methods for doing that, but let's say you decide you want to shave off a chunk of your building, you can go ahead and start manipulating, or if you have a twisty tower, you can you know, keep playing with the form, and then knowing that you can always go back and just update the face of your floor. Okay, we got about 10 minutes. Next thing I want to do is introduce you to the basics of walls and doors so that we can actually start working on floor plans a little bit. I'm going to go into level 1. I'm just going to draw off to the side for right now so I don't have to worry about my my form at the moment. So under home, one of the options here is a wall, of course, and you have different ways of drawing walls. You have your wall, structural wall, and again a wall by face. The wall by face will come in handy when we work with the facade of your building, because that is twisting and turning, or could be, or might not be straight. Revit, if you draw by wall or structural wall, you always have, you know, basically it's going to just extrude a wall straight up. It's not going to slant it or curve it or do anything that conforms to your shape. So these are more for, you know, just your basic walls that you don't really need any kind of structural underlay, kind of a massing underlay to work with. If I click on a wall, you know, a lot of people, when they work in Revit or kind of hear about working in Revit, they'll say, well, you have to know a lot about what is in your wall before you can actually draw it. That's not really true. We can just pick a generic 5-inch wall. I'm going to kind of pretend we're drawing the units of our hotel, basically the different rooms. So I'm going to have interior partitions, and I'm just going to start drawing a generic 5-inch wall. When I select that, I have these draw options. I can pick faces if I wanted to. So if I actually had a crazy form like you see in this kind of pop-up window, you could pick a face of your mass. Or if you just want something to be straight up and down or whatever, we have these other lines, rectangles, and different ways of making an arc. I'm just going to start drawing, and again, you just kind of left click, and as you draw, you have these dimensions that you see. When you zoom in, the dimensions get a lot more detailed. They're kind of moving up in, looks like 1-inch increments. If I zoom out, they might move in 1'6" increments. If I zoom out some more, They kind of move in 4-foot increments. But I can also type in, let's say if I know that this wall needs to be 10 feet, I could type in 10 feet, and that will draw that wall. I'm just going to kind of make a rectangle, and you can see as you start to move up to the next wall, so I'm just kind of moving up. Revit assumes that you want to make alignments with certain things, and you'll start to see kind of these dashed lines that occur. That means that you're exactly aligning to that wall that's adjacent, 10 feet away. And I can go ahead and click on that as well. If I look at this in 3D, you can see I got a box, rectangle. Now, the height of your walls are controlled by constraints. If I click on a wall, look at the properties to the left. There's a base constraint and a top constraint. The base constraint is level 1, because it assumed because we're in the level 1 floor plan that that's where we wanted to draw these walls. The top constraint right now is unconnected, and then it has an unconnected height of like 10 feet. You can draw unconnected if you'd like, or you can actually choose your top constraint, and then it allows you to choose other levels. I could choose level 2, and then this wall now moves up to be 14 foot 8 inches, and the unconnected height is grayed out. It doesn't allow you to edit that number, because in my model I changed all my floors to be 14 foot 8 inches floor to floor, and that's why I have this 14 foot 8 inch increment. Now the reason to set a constraint would be, let's say later on, I decide to go into one of my elevation views. There's my city again, I'm going to VG that. And I go to level 2, and I decide that, you know what, level 2 really needs to be 16 feet. Because I made that wall, if I click on that again now, because I made that wall have a top constraint to level 2, it now moved up to follow wherever level 2 ended up. So now that wall is now 16 feet. Last thing, I'm going to go into level 1. I'm not going to get too involved with all the ways of messing around with the walls yet. We'll have another session on that. But just as you draw, you'll notice that you can draw by wall center line. There's a location. You can look at your options bar here. I can also set my constraint, my height, in the options bar. So I could, as I'm drawing, actually say that I want this wall that I'm drawing to go to level 2. And you can draw by wall center line, core center line, your finished face, exterior, interior, and all this kind of stuff. And I'll get into what all that means. But basically, if you do a finished face exterior and I start drawing, you can see how the wall is being drawn with the dashed line on one of the faces. If I hit the space bar, it flips. So as I'm drawing, I could decide if I'm drawing on the right side. Next thing, if you downloaded that door from the family part of the website, so I told you to download your single family door. The doors in Revit that come with it, I don't really approve of. They don't have the hollow metal door frame. They don't have other options like how to control the door swing. They're just really basic doors. And then they also name the doors in inches. Nobody talks about doors as a 36 by 84 inch door. It's always a 3 foot by 7 foot door or a 3 foot by 6 foot 8. So it's kind of annoying how this is set up. What I would like to do is actually load in a door that I approve of. And what I can do is under home, if I click on door, and this happens with every family, if you're doing a component, a window, or even any kind of structural column, there's a button up here to the top right that says load family. I can click on that, and by default, it's going to go back into our family categories in the Imperial Library. Remember, we were working before in curtain panel by pattern. We were also working with generic models, our masses. I want to go ahead and find that family that I just downloaded. So wherever you downloaded it, go ahead and scroll to and select the door single plane family and hit open. What that will do is it'll load that door into Revit. You'll also see that you have tag on placement highlighted. You can keep that highlighted for now. I'll tell you what that is in a minute. But you'll see that as I hover around and I don't see a wall anywhere, I get the Ghostbuster sign that says no. But as soon as I move in and hover over a wall, I can actually place the door. And you look and you say, well, that doesn't look really nice because you don't see that hollow metal frame that I just told you about. But again, that's because we're in the coarse view. If I turn it to fine, I can get my jams, and it automatically cut a hole through the wall and trimmed all that out for you so you don't have to do all that mess that you do in AutoCAD. And if I select that door, I have a couple of properties already programmed into this that allow me to change the swing of the door. So I could change this to a 45 swing. I could also go into my 3D view and look at this door. Right now everything's just kind of gray at the moment. But I could also pick this door and choose a swing in the 3D view and have it swing open so that if I was modeling or wanting to kind of actually view into this room, I have that ability. A couple quick things with the door. I'm back in level 1. When you click on that door, you notice these little flip arrows. I can flip it by clicking on those arrows. I can also hit the space bar. I'll cycle through. I can do the same thing while I'm placing a door. I can click on door, and as I place it, I can hit the space bar, and it will change how I'm flipping the door around. Now these little pills that pop up that have a little number in them, those are called door tags. And I'm going to delete those for right now, but the reason those actually get placed is as you hit the door command, we had tag on placement selected. So if you unselect that, then from now on when you place a door, and you start having a floor plan as well as you're starting to build the model. So real quick today we went over just how to start creating real Revit elements that are associated with your mass. So you can still play with the design of your mass and you can start putting in real floor plates. And the reason you put in real floor plates, actually putting those floors placed to the mass space, is so that you could turn off your mass and you could be in a floor plan and kind of see the boundaries of where you can build to and what you can manipulate in your floor plan. And then I just started showing you just the basics of walls and how to place doors, kind of the essence of starting to create a floor plan. What I want you guys to do for Tuesday is, well, first of all, you guys need to transfer your drawings from the second floor down to the first floor. Remember, we got to do that by tomorrow, hopefully. You can either do it tonight or first thing tomorrow morning, but it definitely needs to be all up by the Monday is the open house, and I think it starts, there's a little schedule like right when you walk in. You guys probably have seen it. But we definitely need all of our drawings down there, and you guys need to display your work because you're going to kind of be the front door to the college, which is great. The other part is I want you to continue massing. Get a form that you think you like and get it close to the 287,000 square feet or whatever you think your total should be. Remember, I did a 191,000 square foot and then we multiplied it by 1.3 or 1.5. I chose 1.5 just to maximize it. Play with your form, apply real floors to it. You might just apply the, probably most likely the 3-inch lightweight concrete with the 2-inch metal deck, because that's more realistic to what you would normally have. It doesn't matter which one you apply because you can always change it later. The third item, is that 3 or this is the fourth item? Third item is I want you to, somewhere off to the side, and it could even be in another file, but start drawing a floor plan of just one room, of what you think one hotel room should look like. And basically all you're doing is building the walls and you know, placing the doors. And it should be a fairly simple, you know, well, it could be complex, but you're just going to have a couple different rooms. You're most likely you'd have kind of like a living room area, a bedroom area, and then also you know, your bathroom and shower area. Don't worry about placing anything other than doors, and just kind of have something mocked up. Starting to think about how your rooms will actually be laid out. Because if you think about it, we're going to have a lot of rooms, and they will be most likely copied over and over again. That's the kind of the beauty of a hotel. And then we can get into how to make that happen. Look at the program. The program had in it, let's see, under rooms, there's a net area for a typical guest room. There's also a net area for 2-bedroom timeshare units. So kind of more like a suite type of deal. And then there's also areas for balconies. But we don't have to, you can kind of plan in how you might put in a balcony, but you know, just kind of think about it a little bit. You could also just sketch by hand and kind of figure out this what you want it to be, and then start drawing it in Revit. Make sense? So the key is to get that mass, get that worked out.
In our drawings, can we just put the properties and say we need to level 2 or 1?
What do you mean your?
I would say it's it'd be nice if we could do that.
For the rooms?
Yeah, you could just